Let's see this question. This is given in GATE 2005. They are saying that a relation table is having all these attributes, and the functional dependencies are this, and they want us to find out the candidate keys. The same kind of question. So what is the method? One thing is, you could take each option and you can keep on doing the closure, but it is going to take a lot of time, right? Anyway, but the actual method is you try to find out what should be the candidate key, right? The smallest one. Then we shall build it. Okay. So first thing is, we know that whatever is going to be the candidate key, right? It is supposed to cover all these attributes. What are the attributes? A, B, C, D, E and H, right? Now all these attributes either have to come from the candidate key itself, which means the left side, this one, or they have to come from the right side of the functional dependencies, right? So what are the things that could be added to them from the right side of the functional dependencies? If you see this, B could be added and D could be added and C could be added. See, B, D, C and A could be added somehow from the left hand side. I am not saying that it will definitely get added whatever key you take, but depending on whatever good choices, maybe you are likely to add all this, you are likely to add them, right? Now whatever you do, these E and H, they will definitely be not added to the set, that is for sure. Okay, so now one thing is, in all the options, whatever is going to be qualified as the candidate key should definitely contain E and H, right? So based on that, you could definitely cancel out this, right? And you could definitely cancel out this because H is not present in any of these options if you are watching. And now yes, here also it is not, you can definitely rule it out. And here also yes, here there is E and H, therefore this is the answer. You have ruled out 3, and because there is only one option left, I'm getting it as the answer. I'm just marking it as the answer. But then the proof is not just enough, so you are supposed to find out the closure of all the remaining, then only you can declare that these are the candidate keys. Now let us see. We know that every candidate key should contain EH, right? Therefore EH is compulsory. So let me see if EH itself is going to be a key. In case if we definitely need EH, and if EH is a key, then definitely EH is a candidate key. The reason is, we just now declared that EH should definitely be there, right? Which means you cannot remove anything from that, and EH is a key, which means it is minimal as well as it is the key. Therefore it should be the candidate key. In that case you get a unique candidate key. Otherwise, let's see this, let's analyze this. Okay, now let me find out EH plus the closure attributes of EH. Then what do we get? So one is definitely from the left side, you are supposed to add all of them, so E and H gets added, and then you can look at the functional dependency and get them. So I cannot add this, I can add C, right? And then using EH and C, I'll not be able to add any further attributes, isn't it? Just check the left hand side. No left hand side other than this is a combination of EH and C, right? Therefore EH is clearly not a key, right? Definitely every key should contain EH, but EH itself is not going to be the key. Then what should we do? We shall try to add the minimal number of attributes possible to EH and try to see if that makes a candidate key, right? Or if that makes a key. If that makes a key, that will be the candidate key. See, already we know that EH is not the key, therefore we should definitely add something to make it a key, and by adding a minimal thing, if I make that one as the key, that one will be the candidate key, isn't it? Let's see what minimal I could add. So to EH, the minimal thing I could add is one attribute. I'll try to add one attribute and I see if I could make it a candidate key. Let us say we add one attribute like this, A. Then I'll try to find AEH or B, isn't it? Or C or D, right? I'll try to see if they make up the candidate keys. So if this one has to be the candidate key, I'll just find out the closure. AEH is there, right? And now because of E, I'm going to add C, right? And because of A, I'm going to add B, and because of BC, I'm going to add D. I think we got all, right? We got all the 6. Therefore AEH is a key, right? since the closure of this contains all the attributes, AEH is a key, and we know that this is the minimal key. The reason is, I'm not saying minimum, it is minimal. Minimal means you cannot remove any of the attributes from this and you could still make a key. See, you cannot remove A, because if I remove A, we just found out that EH is not good enough, and we cannot remove E because we can never derive E without E, and we cannot remove H because the same reason, we cannot get EH without H. Therefore this is a key and it is minimal, so it is also candidate key. So this is a candidate key. Got it? Now what about this one, BEH? Again, same thing. Let us find the closure. So one is B, because of BEH I get BEH, and now because of E I get C, right? And because of are you following it? Because of E here I got C, because E determines C is there, and because of BC I get D, and because of D I get A. I got everything, right? Therefore BEH is also a candidate key. It is key and it is minimal, it is a candidate key. Got it? And what about CEH? Let's see this. So I'm going to add CEH here, and because of E I get C. C is already there, and because of nothing, I cannot add anything more, right? Therefore CEH is going to give us only CEH, right? So it cannot be a key, and so it cannot be candidate key as well, right? Now what about DEH? Let's see this. Now in order to make DEH a candidate key, we should find it out. So DEH. Now because of D I can add A, right? And because of A I can add B, and because of E I can add C. Everything is added, right? Therefore this is also a candidate key. Got it? So these three are candidate keys, right? And what about this one? This one failed. CEH failed to be a candidate key. Now let me see if CEH added with something else might become a candidate key. Now if I have to add something to CEH, the minimal part, what should I add? What are the options I have? Only options I have is A, B and D. So from only A, B and D I have to take an attribute and add it here. But if you try to add A to this, right, already AEH is a candidate key, therefore ACEH cannot be a candidate key, it will be a super key. Or if you try to add B to this, again BEH is already a candidate key, so BCEH is not going to be a candidate key, and same thing with D. Therefore you cannot do anything with CEH, and you cannot get one more candidate key. Therefore we have only 3 candidate keys, right? Then what about the number of super keys? We can use that formula. What is it? The number of super keys possible with this as the candidate key. How many number of super keys are possible with this one as the candidate key? We have totally 6 attributes. 3 attributes are already included, and from the remaining 3 attributes I have 8 combinations. Therefore each one, this one is going to give me 8 super keys, and this one is going to give me 8 super keys, and this one is going to give me 8 super keys. Along with that, you have to use that formula. What is it? The number of super keys possible with 3 candidate keys. So I already told you, if I have 3 candidate keys K1, K2, K3, then the number of super keys possible with 3 candidate keys is, you have to add the total number of super keys possible with each one minus the total number of super keys possible with K1, K2, K2, K3, right? And K1, K3 union K1, K2, K3, right? So you have to take a combination of all this. This is going to be the number of super keys. You please do that. It is going to be a lot of time, but anyway it is not required here. What you could do is 8 plus 8 plus 8 minus K1, K2, which means containing both this, that will be ABEH, and then containing both this, that will be DBEH, and then containing all these 3, which means ABDEH, right? And you can subtract it. We have already seen that numerical. You can find it out, right? Okay, anyway the answer for this question is D, right?